Hey everyone, welcome to today's Explainer. Today, we're taking a look at a genuinely fascinating project created by developer JeffreyRed on GitHub. It's simply titled mini-GPT. You know, if you've ever looked at those massive artificial intelligence models and thought the underlying mechanics were just completely locked behind million-dollar supercomputers and impenetrable code, well, prepare to have your mind changed. Today, we're going to break down exactly how you can understand the absolute core of modern AI, right from your own laptop. Okay, let's dive into this. Can you really build a functioning GPT in just 2 minutes? The answer is a resounding yes. One of the most incredible aspects of this mini-GPT repository is just its sheer accessibility. We aren't talking about weeks of processing time here. This entire model trains in just 2 to 4 minutes on a standard CPU. And hey, if you happen to have a GPU, you're looking at a training time of under 30 seconds. It's an incredibly rapid-fire entry point into the world of large language models. But how is it literally that fast? Well, it all comes down to one number: 50. Instead of scraping the entire internet for billions of words, this entire mini-GPT model is trained on a tiny, meticulously curated dataset of just 50 Albert Einstein quotes. It completely strips away the noise and that massive computational overhead, leaving us with a pure, concentrated playground to understand exactly how machine learning text generation actually works in practice.
So here's our roadmap for today. First up, 1. Meet the mini-GPT. Then 2. Upgrades under the hood. 3. The overfitting feature. 4. Generating Einstein. And finally 5. The next steps.
Section 1. Meet the mini-GPT, Step 4 of the mini-LLM series. So this project is kind of the crucial bridge between abstract AI theory and real text generation. Up to this point in a developer's learning journey, everything is just theoretical plumbing. Mini-GPT is where the water finally turns on. It's Step 4 in a really comprehensive 7-step mini-LLM series created by JeffreyRed. It builds directly on top of the foundations laid by Step 1, which handled word vectors, Step 2, tackling self-attention, and Step 3, the mini-transformer. Step 4, our mini-GPT, is the milestone where we finally apply a full language model to real recognizable text. Section 2. Upgrades under the hood, advancing from the mini-transformer.
Now, what's really interesting here is the massive contrast in sophistication. The previous step, the mini-transformer, was pretty basic. It used just 10 toy sentences, a fixed mathematical sinusoidal positional encoding, and a standard atom optimizer. But mini-GPT scales that up to 50 real quotes. And even more importantly, it swaps that fixed encoding for a learned neural network embedding. It actually learns how to position words on its own. Plus, it upgrades to the atom W optimizer, introducing weight decay to really manage the model's complexity.
But the upgrades absolutely don't stop there. mini-GPT introduces an 80-20 split for training and validation data, allowing us to track performance. It also uses something called cosine learning rate decay. Think of this like studying for a massive final exam. You study incredibly hard and fast at the start of the semester to grasp the big concepts. That's your linear warm-up and peak learning rate. But as finals approach, you slowly taper off your studying, letting the rate decay, just to fine-tune the details without forgetting what you already learned. It also adds advanced generation tactics like top P nucleus sampling and beam search. Plus, it automatically saves your best checkpoint. It's got the whole shebang. And this is just incredible to think about. This model only has about 40,000 parameters. For context, the commercial AI models making headlines today have billions, sometimes even trillions of parameters. Yet this tiny, lightweight repository uses the exact same enterprise-grade mechanisms like atom W, cosine decay, and nucleus sampling. It's the same architecture, just scaled way down so you can run it on your coffee break. Moving on to Section 3, the overfitting feature, when memorization is the goal. This is perhaps the most surprising educational twist in the entire repository. To understand it, we first need to define the term. In traditional machine learning, overfitting is when a model essentially memorizes its training data completely rather than learning general, flexible patterns. It's like a student memorizing the exact answers to a practice test, but then totally failing the real exam because they didn't actually understand the underlying math. In data science, overfitting is usually considered a cardinal sin. So the crucial point is, in this specific project, overfitting is absolutely not a bug. It's the intended educational outcome. When you feed a 40,000 parameter model a dataset of merely 50 sentences, it has so much brain power relative to the data that it is inevitably going to memorize every single word. And for this exact step in the mini-LLM series, that is perfect.
Memorizing the data proves beyond a shadow of a doubt that the underlying architectural plumbing is successfully routing the information. The repository's default configuration intentionally drives the model to overfit. Running the model for 400 epochs totally forces that overfitting signal. And that 20% validation split, that's there specifically so you can visually track this happen. When you run the code, it actually generates an overfitting plot comparing the training perplexity against the validation perplexity. You get to watch the exact moment the model stops learning general language and just starts memorizing Albert Einstein.
Section 4, Generating Einstein, Bringing the Quotes to Life.
So we've intentionally let it memorize our 50 quotes. What happens when we ask it to actually generate text? Well, because it memorized the training data, if you use standard greedy generation, it'll simply spit out exact Albert Einstein quotes from the training set. You'll input a starting word, and the model will rapidly autocomplete with something like, imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world. It has essentially become a perfect digital parrot of the great physicist.
But hey, we don't just want a parrot, right? There is a massive difference here between greedy generation and beam search. Greedy generation is really rigid. It just looks for the very next most likely word, which leads straight to reproducing those exact quotes. Beam search, however, evaluates multiple branching paths of words simultaneously to produce the most highly coherent overall completions. It's basically the difference between walking blindly, one step at a time, versus looking a mile down the road before choosing your path. And this brilliantly illustrates how you can interact with it. You can actually fight the model's urge to just parrot quotes right in your command line. You can increase the temperature to make the output way more random. You can use top K or top P nucleus sampling to force the model to pick from a wider pool of possible next words. You literally get to manually pull the levers of AI generation and watch the results change in real time. It's super cool. Finally, Section 5, the next steps, moving beyond memorization. So we've built a model that works flawlessly, but right now, it's stuck in memorization mode. But the beauty of JeffreyRed's series is that every problem perfectly sets up the next solution. Step 5 of the series, called mini-chat, is explicitly designed to fix the overfitting issue we just explored. It does this by moving away from just 50 quotes and introducing a much larger dataset. Furthermore, it shifts the entire architecture from simply predicting the next word to following prompt-to-response instructions. It's teaching the model to converse rather than just recite. And here is the roadmap for that final evolution. After we conquer chat in Step 5, Step 6 introduces a cross-attention module to align source and target data. All of this culminates in Step 7, the mini-translator. By the end of this journey, these exact same scaled-down mechanics will have built a complete English-to-Spanish encoder-decoder model. It really puts the immense power of machine learning into perspective. We've seen today how high-level concepts used by the biggest tech companies in the world can be stripped down, deeply understood, and executed on a personal computer in the time it takes to brew a cup of coffee. So I'll leave you with this final thought. If just 50 sentences can teach a 40,000 parameter model to speak exactly like Albert Einstein in just 2 minutes, what could you build next? Dive into the repository, tweak those parameters, and find out for yourself. Thanks for joining me on this explainer, and keep learning.